In today's video, I'm going to be replacing downlights in my living room. And I don't quite know why I'm filming this, like I should just do the work and not actually film it because that would be much quicker, but I thought people might find this a bit interesting. But yeah, in my living room I've got 9 GU10 downlights. I'm going to replace them with new ones. And the new ones I've got are quite interesting, they're slightly unusual, so I wanted to make a video showing them as well because there isn't really any decent reviews of them online. There's just a few written reviews that do rate them quite highly, but then the only video content is just some manufacturer animated videos that are pretty much useless, so I sort of wanted to do like a review of these downlights as well. But yeah, in my living room currently I've got 9 GU10 downlights, and they're just sort of standard, sort of brushed metal GU10 downlights. I've got them throughout the flat. I've got this particular type in the living room, office and bedroom, and then a slightly cheaper, older type in the kitchen and hallway, so I might replace those too. And they're decent fittings, they're just sort of standard twist lock GU10, so they twist, drop out, fire rated cans, and then the bulb just goes up and twist in like that. And to be honest, I quite like them. I don't really need to replace them, to be honest. But part of the issue with these is that the holes they're installed into are far too tight, so they're really hard to get out. In fact, you basically can't get them out without destroying the ceiling. So I've done a bit of testing over there and there, and I figured out the only way I can really to get these out is to lever them down, stick a screwdriver up the side, and basically snap the spring off the side of the light to get it out the ceiling. And that's not great because even though it's not the intended design of, or use of downlights, for running cables, I find downlights to be super useful because if I want to route cables around this room through the ceiling, I can pop the downlights down, run the cables, and put the downlights back up. But with these ones, I can't do that because I literally will destroy the ceiling. So I wanted to fix them anyway and at least put them in bigger holes so they can come out easier. But given I have to basically destroy the downlight to get it out, I mean, it is fixable, but it's not great. I'd be needing to replace the downlights anyway, so I wanted to replace them with a sort of nice new design, so I'll take a look at the ones we're fitting. But yeah, these are the current ones, and they're absolutely fine. And yep, I've gone with GU10 ones. I really don't like integrated LED fittings, and I don't really get the appeal of why so many people just fit them and rave about them. And I'm going to rant now, but I always rant in my videos. But yeah, the problem with integrated LED fittings in my mind is, first of all, if they do fail, they're harder to replace. You need to get an electrician in, or at least be competent enough to do it and go up a ladder and change the wiring, which doesn't bother me that much because it is possible and they do last a long time. My problem is if you imagine a room like this where there's 9 downlights, even if like 5-10 years down the line, one of these were to fail, if it's an integrated LED light, that's a total pain because chances are they don't make it anymore. So you're either going to have one totally mismatched light or you'd have to replace them all. Whereas with GU10s, realistically, these bulbs can fail as often as they want because I can just replace the bulb and leave the fitting in the ceiling and have all the fittings matching. So yeah, that's my main reason I'm using GU10 fittings. But also these are smart bulbs. You can get smart integrated fittings, but that's probably even worse because they're even less replaceable. But yeah, these are also smart bulbs in there as well. And one of the sort of motivations for replacing them, apart from the fact they're stuck in the ceiling, is just in terms of the design, they're quite noticeable. Personally, I really like metal electrical accessories, so all my sockets and switches are all metal. And when I got the downlights, I thought, I'll go metal as well, that makes sense because they'll match all the sockets and switches. But what I hadn't really clicked is that these are on the ceiling. And when you walk into the room, they very much catch your attention. Especially here where the ceilings are pretty low, like I've got really low ceilings in here. Having the very noticeable downlights just draws attention to the fact the ceiling's really low. So we'll take a look at the new ones I'm going to be putting in, but they should also be a lot more discreet and a lot more subtle against the ceiling, especially when they're not lit up. So yeah, in this video we'll take a look at the new lights, do a sort of tour of them, talk about them, why I've gone for them. I'll then go away and install them and I'll give a sort of review. Hopefully it won't be too long a video, but yeah. That is all the lights, and there's obviously a couple hanging down that I've taken out just to try and work out if I can force them out without damaging the ceiling, because yeah, that's what happens if you try and take them out without breaking the spring, basically snapping the springs off the lights. They just stick in the ceiling and rip the plasterboard down. And just before I go and take a look at the new lights, we'll just take a look at one of the original ones I've pulled down. So as you can see, they're just standard fire rated GU10 cans. Obviously the springs have been very much snapped off that, but there would have been springs there. They're decent enough fittings. I think these are just fairly generic brand ones, but they're decent enough and they're all fire rated. But they're quite an old style. You know, they've got the big holes in the back and intrumescent seals, and that's because this is designed for halogen bulbs where you need to let the heat out the back. There's a lot of really interesting downlights, like the new ones I'm fitting in, that because they're only designed for LEDs, not halogen, have been able to do away with a lot of this fuss and bulk because they don't have to deal with halogen and the heat they produce. Because that was a bit of a pain to really fit up in the ceiling and pull down, and it's just bulky. In terms of wiring, you'll see there's a little bit of additional stuff here. And that's because the way the lights in this room are wired is a bit different. Obviously now so this room has smart bulbs. They're all powered through a single key switch. I made videos on that previously. But originally I had two separate switches on the wall. The first one controlled the rear row of lights. The second one controlled the front two rows. And that was really good because it meant you could turn on just the rear row and not have the room super bright. And before I had the smart bulbs, I absolutely loved it. But for that, what that means is the main lights are all wired in 3-core and earth cable. And that basically means that the cables that go through all the lights have have a neutral, an earth, and 2 lives. And each live was switched independently. And the idea behind that is that because the 2 lives are available at each light fitting, it would be very easy to sort of pop up in the ceiling, adjust the wiring, and swap the lights between zones. So you could decide actually you want one switch to control the back 2 rows and then the front row to be controlled separately. You could relatively easily do that. So that's why there's a separate junction box here. Because obviously these downlights just have a 3-pole, just live, neutral and earth in on the junction box in there. So this junction box here takes the 3-core and earth in at the top and just allows the 3-core, or sorry, twin and earth to come out the bottom to go to the light. And then there's the two switch lives, the one labelled 1 and 2. So you can move that wire from there into there and choose basically what switch it's switched off of. I was semi-tempted just to replace it all with twin and earth and just do away with that just to simplify stuff. But I do like it, and obviously in the future, I might not keep smart bulbs forever. Obviously when I move out way in the future, I'm going to be taking the smart bulbs with me. So actually having this functionality just with 2 switches is actually quite nice, so I'd rather reinstate it. But these junction boxes are a bit tacky, so I've got a nicer solution I'll be putting in as well. So let's go and take a look at the hardware we'll be fitting. And here we have the stuff we'll be using. So these are the downlights I've gone for. And these are the integral LED EvoFire. And these are the recessed model, which is what's interesting about them. These lights are designed to reduce glare. So what they do is, as you can see here, they hold the bulb a bit further back from the ceiling. So it's actually recessed into the ceiling a bit. And that means when you're sitting side on or if you're across the room, you don't get as much, or shouldn't, I've not tried them, you shouldn't get as much glare from the bulb itself. So that could actually be quite nice because I'm really sensitive to like lights in the corner of my eyes, and like I get dazzled really easily. You know, if like there's a bright light, I see it in my vision for ages afterwards. So it's really nice if these help. They might not, but hopefully they will. But they also just look really subtle and discreet against the ceiling from what I can tell, because they've only got like a 1 mil thick piece of metal because there's no big screw mechanism or anything like that. So that should actually be really neat, and so it'll be interesting to see what they look like. I've also gone for white ones because I honestly couldn't decide, but then after looking at my ceiling and realising how visible the downlights are, I think the white ones will look a lot more subtle, which will be really good. And these are quite an interesting design because they are fire rated downlights, you know, fire rated there, they're all up to 90-minute fire rated. If you look at this proper specs, it talks about I-joist, it's tested against all modern construction, it's got all that sort of stuff. But they've basically gone back to the old style of doing away with a big metal can at the back, and apparently all the fire rating is done by the metal and some fireproof glass in front of the bulb. I mean, apparently, we'll see. The downside of this is you do have to remove the entire fixture from the ceiling to change the bulb, but with LEDs it's not as bad. But because it's not got the big can, and hopefully the springs aren't like mouse traps like on the current ones, they'll be much easier to get out of the ceiling. What they also state here is that because they're canless, they let heat dissipate into the ceiling and the bulbs don't get as hot. How big a deal that is, I don't really know. These are only designed for LED as well. You cannot use halogens. Well, I mean you could, but it does say not to use halogens with them. It's only for LED. But if that makes the LEDs run cooler, I suppose that is maybe quite good. So yeah, just interested to try these out because they seem pretty well rated. There's loads of really good reviews. They're available from lots of reputable places. It's not just like one dodgy place selling them. Integral LED is quite a big brand, or an up-and-coming brand of LED and downlight and stuff like that. Seems to be decent quality. I've used their stuff before. And yeah, it just seems like quite a neat design. But the main reason I went for these isn't for the canless design or anything like that. It was for the recessed design, because I have seen recessed downlights before, but they've all been integrated LED, and I've wanted to be able to put a GU10 bulb in and use smart bulbs. And this is the first one I've found that's reasonably priced, because these are only about £7-8 each, and has a recessed lamp, which is really nice. So yeah, that's downlights. Now you'll notice I have 2 different types here. This wasn't intentional, it was just a classic case of them not having stock of one type, so I had to buy a bit of both. But also this lets me show the range in the video. Because these are basically identical, except this one has an insulation shield on the back. So whereas this design is just literally the bulb onto the back of the light, that one you can't put insulation over it. Whereas this one's exactly the same, it's just got this additional bit of metal over it, it costs about £1 more, and that means you can lay insulation on top apparently. So yeah, that's why I've got both. It means I can show them both in the video and talk about them both, but realistically the only reason I got them is just because they didn't have stock of this one, enough stock to buy 9 of them. Because I've not got insulation above the ceiling, so that's fine. In fact, this ceiling doesn't technically even need fire-rated downlights because there's a concrete ceiling above, so the actual fire barrier is a concrete floor between the two flats, but I tend to just use fire-rated anyway because why not? May as well have that bit of extra safety. Also, these are IP65 rated, so I could use these in the bathroom. My bathroom's currently got JCC FireGuard Next Generations, which I really like, but I do need to put downlights in the other bathroom, and actually the idea of having totally matched downlights throughout is quite good, although I probably wouldn't use recessed ones in the bathroom, I'd maybe use the standard one, because they do have a non-recessed version of this. Yes, I'm rambling a lot, we'll take a look at them in a second, but the final thing is this connector here. So I mentioned those junction boxes are a bit naff. Yeah, they work, but I'm not sure. I'm just not a huge fan of them. So I've just decided to try something different. So these are just a sort of push-fit junction box. So the way that works is that comes off here. You've got 4 connectors in there. Neutral, earth, live, and then a second live. The first 3 are connected through to these connections here that plug into this. So you can just look through the second live and have one of the lives connected into this. So I'm hoping this could be quite neat. What I can do is I can replace those existing junction boxes with these, just as like a direct one-for-one swap. And then these can sit in the ceiling. I can wire these onto the downlights and plug the downlights in like that. So we'll try these out, see how we get on with them really. I like trying new things like this just to get ideas or just see what sort of products there are out there. I'm very sad. But yeah, without any further ado, let's take a look at the downlights. So we'll start off with the basic one. This is the one that's not coverable by insulation. To be honest, chances are, if you're installing this on a lower floor of a house, this will be the one you'll go for. If you're installing this in an attic, these ones. But yeah, here it is. So let's see what you get. Also, you get a manual. And like an old-fashioned downlight, because it's not got the big can, it just comes almost like this. So you get these 2 different parts. So you get the metal downlight can there. And as you can see, that's all solid metal. There's a little silicone gasket. That's not intermittent or anything. I think that's literally either to... I'm not sure. It's either to stop moisture ingress in the bathroom, or it's maybe like the sort of rubber gasket you get behind metal sockets and switches, so if you're installing it on a freshly plastered ceiling, it doesn't damage the metal. I'm not sure. Part of me thinks, like, if you took that out, it might actually sit flush with the ceiling. I'll take a look, but you might be meant to keep it in there for design, I don't know. But yeah, there's a little rubber gasket there. And then here, I'll tap this side so I don't get fingerprints, there's a bit of glass. And this is how they're maintaining this fire rating. They've got this steel downlight with this fireproof glass. And I suppose that makes sense. I mean, glass is pretty fire resistant, steel's pretty fire resistant. I don't really see, if you've got this, why you'd really need a big can on the back as well. So yeah, that makes total sense to me. Then you've got this junction box here, lamp holder, and an earth wire connecting them. So we'll take that little elastic band off just to get the lamp holder out. There we go. There's a standard GU10 lamp holder with a sort of strain relief in the back. And as you can see there, it is labelled with LED only, max 10 watt, which makes sense. I think that's because with these old downlights, when you had the ones with halogen that didn't have a can, part of the issue with them wasn't even sort of fire rating of not having a can. It was where you'd have a really hot halogen bulb and a cable or the transformer or something would fall onto the back of the light and it would end up melting, and I've seen that before. I've seen transformers, the whole melted out the side of them, which isn't great. So I suppose that's maybe the other reason they're saying LED only, is just you don't want to put halogen in that because you've then got that risk back. Whereas realistically, you can hold an LED bulb in your hand and touch it and it's hot, but not dangerously hot. So I can't see an issue with having that just sitting above the ceiling without any can around it. It's just an LED bulb. They don't get that hot nowadays. So yeah, that's what you get there. As for the springs, yep, they're springy, but they're not like the old ones. I'm not going to stick my finger under that. It would probably still hurt, but this seems like the sort of thing I could easily get out the ceiling without destroying the plasterboard. Those old ones were ludicrously tight, so yeah. Because the downside of these is you do have to take them out the ceiling to actually change the bulb. So that's a little bit annoying, and it is a downside over the twist lock ones. But realistically, it's a trade-off for the aesthetic. You get a super clean downlight with no visible way of removing the bulb at the front, which looks really neat. It's just a trade-off when you need to change it. But yeah, that's that downlight there. Now, as for the electrical side of things, you've got this junction box here. And if you open that up, it's standard push-fit sort of piano keys type junction box. Dead simple. I'm not even sure if this is even actually like made for this bulb or this light fitting, because it just says like junction box. It's got like another company's logo on it. So I don't know if this is just actually an aftermarket or a third party's junction box they're just using. It's such a simple design, this makes sense because it doesn't need to attach this or anything. I think with my install here, I'm actually not going to use this, just because what I need here is I need some sort of external junction box to handle that 3-core in earth. So either I use the existing junction boxes or I use these, which is what I've decided to use. But to me, it just seems silly to take this, have a cable from this into another junction box, and essentially just have junction boxes into junction boxes, when instead I can just take the lamp holder out of this, wire the lamp holder into this connector, and just have that instead. So I don't think I'll actually use this junction box, so I will have to say I'm not going to be reviewing this particular part of it. But it comes with a little junction box, but I'm just going to wire it into this. Can't really see a reason not to. But yeah, it seems okay. It will be quite tight to wire inside there, but it will be doable, so there's no excuse for having insulation hanging out. You would be able to do that, so yeah. That's the junction box there. And that'll clip shut like that. So yeah, seems pretty neat. Definitely quite like that. Space for looping in and out, yeah, all seems good. Now the other thing you'll notice here is this earth wire tying the junction box to the light fitting. And interestingly, this actually isn't really required. On the box it says it's a class 2 fitting, and the manual states that the earth is provided for your convenience. So, as far as I can tell, you don't actually need to use this on an earth lighting circuit, which is quite good. Obviously, mine's all earth and the earth carried throughout, because why wouldn't it be? But in a lot of older installs, you might have lighting circuits wired in 2-core cable, or you might have one where someone's inexplicably cut an earth out and you can't find where they've done that anywhere. This could actually be quite useful that you could use these. It does therefore feel a bit weird that they've actually even bothered connecting the junction box to the fitting if apparently it doesn't need it, because this does just hold a GU10 bulb. There's no like single insulated cables hanging around this, so I don't really see why it needs to be earth. But it's nice to do it anyway, may as well. And this just gives me another very random thought, and I know I'm going on tangents in this video. Another benefit of this design actually could be for smart bulbs. Because currently my smart bulbs are Zigbee wireless smart bulbs, also get Wi-Fi ones, and you're putting that inside an earth metal enclosure, which surely won't be good for the signal. Whereas with this, the bulb's actually sitting above it and isn't inside a sort of Faraday cage, so that could actually help the signal on smart bulbs as well. Just an interesting idea. But yeah, according to the manual and the box, these don't need to be earth, but there is just an earth wire here for your convenience according to the manual. And one thing I've had noticed as well is, even though it doesn't say that it's class 2 on this itself, what it does say though is that it is fire rated. It states there the fire rating. And this was something I was kind of worried about, and I'm glad they do put that on there, because this doesn't look like a fire rated downlight at first glance. And my fear would be an electrician coming along doing the ICR that hasn't seen this particular model before, taking it out the ceiling going, no, that's not fire rated, and then charging the customer to replace them with fire rated downlights, even though these are fire rated. So it's good to see it is printed on that, so hopefully people actually read that if they're not sure about the fire rating of this and don't just assume from the form factor. But yeah, that's that downlight there. Seems pretty nice. Feels pretty good quality as well, and it's really thin, so that'll look great against the ceiling. So yeah, that's the sort of standard non-insulation coverable one. We'll very quickly take a look at this. As I mentioned, it will just basically be identical. It'll just have that metal bit on the top, but we'll take a look anyway. So as you can tell, I was telling the truth, it is just exactly the same with a metal bit on top. So yeah, your bulb goes in there, but it's now got this metal piece on top that'll keep insulation off the light, so that's pretty neat. As you can see, earth bonded again, same junction box, same lamp holder. It's literally identical, so that's why I bought this, because from the front, they look exactly the same, so it doesn't really bother me having some of them like this, some like this. I mean, it probably will bother me because I do get bugged by things like this, just knowing that it's there even though I can't see it, but I'll try and arrange them in an aesthetically pleasing pattern with alternating between them so it doesn't bug me too much. But yeah, that's two different types there. So if you've got insulation above it, go for that. If you've not got insulation, go for that. If you can't get this one and you've not got insulation, that one will work too. So yeah, that's two lights there. And it's just interesting to see what they're now able to do because with LED lights, where they don't now need that huge can and they can just make a fire rated downlight with just a bit of metal and the fire rated glass. That's pretty nice. So yeah, time to go away and get these installed. So now I've got the unenviable task of taking all the existing lights out, which involves forcing the springs off the screwdriver, but I'll get them all popped out the ceiling, and then I'll come back, well, get them all popped out the ceiling, get all these junction boxes installed, and get these lights connected up. Oh, and I've also just noticed that the box does state that it's a class 2 product, so yeah, you don't need to earth it, but you can if you wanted to. But that's actually something just that's, again, jumping all over the place. It is really good that they have actually included an earth terminal in the junction box. And now that's a low bar to set that I'm happy that they do include it, because that surely should be standard. But not all downlights include that earth terminal. The downlights I have in the kitchen and hall are fairly cheap old Screwfix lap ones. And they're class 2 as well, so they don't need to be earthed. That's fine. But there's no earth terminal in the junction box. So on these ones, there's an additional terminal had to be added in, and then that connects the earth through, so that's all okay. But on how many of those installs are people just going to put them in, go, oh, there's no earth terminal, and cut the earths off, and then not have the earth continuity through the cable, which you're not allowed to have. So yeah, it's good to see this, because that'll at least encourage people to not cut the earths off. So yeah, that's the thing. Doesn't need to be earthed, but it has a connector if you need it. So I'm currently working through removing the downlights, so I thought I'd just make a quick clip just to sort of try and explain roughly how I'm taking them out, because this could be quite useful for people who are like me and they have downlights stuck in the ceiling that they can't get out without damaging the plasterboard, especially if the hole's too small, which is quite common. So just to roughly demonstrate, I've got a downlight here, and as you can see, standard downlight's got a spring on the side. This is the same model that's installed in the ceiling. And then basically what I'm doing, and I'll show you up at the ceiling in a second, is I'm easing it down and sticking a screwdriver up the side. And the screwdriver does damage the plasterboard a little bit, like, you know, creates a little crater where that's going in, but that's enough that it'll be hidden under the bezel. And then what I'm basically trying to do is, if you imagine the springs there, I'm absolutely going to trap my finger in this, but so basically the spring's in, but what I'm basically doing is I'm trying to then get this screwdriver under that sort of piece there, and then I'm just levering it until essentially this piece here bends up. I've got one here that I've done it to, and as you can see, this bit here bends out the way. Once that happens, this corner of the spring pops out. I then push it back up into the ceiling, swivel it a bit, and in doing that, the spring pops off, and you hear the spring ping off and land on the ceiling. And once that springs off, that side of the light will sag down. And then all you need to do is do the same for the other side. So I've already got one spring removed from the ceiling, so I'll go up and show what I've done there and try and explain it. Hopefully this is vaguely clear. But yeah, I'll go up and show what I've done at the ceiling, and then we'll hopefully be able to get them all down. Okay, so here I am up at the ceiling, and as you can see, I've now removed one of the springs, so that light now sags down on this side. And as you can see, the only damage is a little slot there where that screwdriver's been pushed through, just get enough of an angle to get it under that spring. But that's good that that'll perfectly cover under the lights, that's totally fine. And even these new ones, the bezels are actually, I think, a bit wider, so that'll totally cover that damage, which is good. And compared to blowing out the plasterboard, that is much better to deal with. And even if you did see it, that's dead easy to fill. A big cracked out plasterboard is not easy to fill. Well, it is, but it's not as easy as that. So yeah, that spring's now out. Now obviously there's a spring on the other side, so I've got two options there. Either I just do the exact same on the other side. I ease it down, go around, try and get up to get to that spring. Totally going to fall off the ladder holding the camera, but spring's up there. So I can do it on the other side. But what I've been trying to do, I can't do it on all of them, but on some of them, I've been able to rotate the light round. Of course, it depends on the tightness of the cables, but I've been able to sort of rotate the light round until the spring is on this side. Because now I've done that, the spring that's working is now, you won't be able to see it, but is right above that hole. So now, with it rotated, I can use the same sort of hole in the plasterboard I've already made with a screwdriver to force that other spring off. So yeah, this seems like an okay trick to get them out the ceiling if they're totally stuck, so yeah. And to be honest, you probably could put the springs back on. If you bent that bit of metal back into shape and put a spring back on, you wouldn't want to do it multiple times, but you could probably get away with it at least once. But yeah, time to bend that down, break that spring off, and get yet another downlight out. Okay, so I've now pinged the spring off the other side. So as I mentioned, when you first unclip it unclips from one side, you rotate the light and it pings off. Same here, so that spring's totally removed. This side I've sort of forced it with the screwdriver and it's unclipped, but because of the tension it's still sort of hanging on there. But now if I wiggle this, you'll hear the spring ping off and the light will fall down. So if you listen carefully, you might hear the spring ping off. There we go. So just that bit of rotation after pinging it off one side, because it's come off the other side, spring totally drops off. So now that whole thing will come out and you can definitely see how too tight that hole is. And then out comes the light and also the junction box will come out as well. There we go. So yeah, that's my trick to remove downlights that are stuck in the ceiling. And then obviously if you stick your hand up, you'll probably find the springs. If not, what I've actually ended up using is jump cut. What I've ended up using is this, which is part of the Super Rod Mega set. It's just a really flexible sort of cable rod with and then I've added on the magnet on the end. These are separate parts, so you can put those on the bigger rods. But even just using this small little rod with the magnet is enough to sort of fish up into the ceiling, and you can move it around and you can use that to grab the spring if it's sort of a bit further away, which is quite useful. Obviously in this situation I'm probably just going to chuck these downlights out, but I have actually managed to lose a spring before where I've put the downlight up, caught it, the spring's pinged off and gone flying, and I've had to actually replace the downlight because I've not been able to find the spring. So that magnet's really useful as well. But yeah, that's what that went out. So one more light over there to remove. Then I can finally get to replacing these junction boxes with those new connectors and getting new lights in. Because that would be really nice right now because it's quite dark. It's gone dark outside and I've just got a few lamps to actually see. So yeah, definitely be nice to get lights back on. So there we go. That's all downlights pulled out. I'm a bit more relieved now because this was my fear. If I was going to start destroying the ceiling, taking these out, it just makes this whole project a lot longer. But I've been able to get them all out and really create no damage that won't be covered by putting a new light in there. So dead happy with that. So I now know from now on that I can definitely finish this project without issues because the rest is easy. So yep, all I need to do now is take all those downlights off and then replace those junction boxes with the new connectors. And as you can see, I've already started putting one on here, and then over here I've got one that's actually wired in. So that one's wired in there, so I just need to do that to all of them. And then this one here is just the first one on circuit. That cable comes up from the switch. So obviously this is all obviously isolated. So what I've done is I've left the first one disconnected. I'm going to connect all, leaving the first one disconnected, because I've got a split load RCD consumer unit. And the problem is if I connect the neutral and the earth into this, as I go through and cut cables and stuff, I'll just end up shorting neutral to earth constantly and trip the RCD, which is a total pain. So what I tend to do is if I can leave the neutral disconnected at the start, that way I can go through, if I touch neutral to earth, it won't matter because it's disconnected, and then only do this connection last, because otherwise I'll just be tripping the RCD constantly. I can also disconnect the neutral at the switch, but this is easier, so yeah, that's why that's disconnected for now. So I'll go through, get the rest of the junction boxes all on, and I'll finally connect this one up once I'm ready. Okay, so that's all those connectors installed. They're okay. I mean, they're screwless connectors, so they're relatively easy to do. It's just with 4 wires, they're just, or essentially actually 8 wires in each, because there's 2 cables. It does just get quite fiddly. It's not crammed, there's loads of space, it's just fiddly to get them all cut to the exact length and bent into position. But I've got them all in. Didn't need enough job, so not too worried about it. See there, so little wires in the back, so relatively neat. And what I've done in these is obviously they've got the loop connection and then they've got the live that actually comes the connector. So on the ones at this side of the room, I'm using the brown wire for the live that connects to the light, and on that back row I'm using the black. So that just keeps them separate. So they're still switched separately, so if I did get rid of the smart bulbs, they'll still be switched as they were before, so yeah. In hindsight, I should have just taken it out and just put it back, but I did like how it was wired and how I could have the 2 switches, so I may as well keep it in. Just it took a lot more effort. Although on the plus side, if I do like these downlights and want to put them in other rooms to replace the existing ones, it'll be a lot easier to swap the other ones out. But yeah, that's done. So what I need to do is go and put the connectors for these, like the other end of this, the connector side, onto the downlights, and then get them in the ceiling. Okay, so we've got the last one left to do, so I may as well show it on camera. So we've got a downlight and the original junction box I showed before. That comes off just to reveal this piano keys type connector. Very standard little connector. What we need to do is remove the wires from the back of this connector here, so we can fit on the new connector that fits onto those junction box things. So what we need to do is take that piano keys connector off, and while it looks like those aren't removable, they're just sort of stuck in the back, you can actually get them out. It has these little holes that are like a T shape, and what you basically need to do is push a wire down into that hole while applying very gentle pressure to the wire that you're wanting to remove, and that will actually release it. It's a little bit fiddly, but once you get the knack of it, it actually works. And that way you're not having to force them out, you're not risking damaging it, you're not damaging the connector, nor are you going to damage the wire. You just need to hit the right thing inside here. Doesn't help the wire's a bit bent. But once you get the right piece, or right bit inside, you can relatively easily release the wire. There we go. Obviously, never works when you try it on camera, there we go. A little bit fiddly, but that's out. So now that's removed, what we now have is the lamp holder with 2 wires on the end and the earth. And what's really good is these are all ferruled. They've got little ferrules on them, so that's really nice, because unfortunately on these connectors, while the main junction box part is push fit, these plugs are screw terminals, so it's nice to have them ferruled so I don't have to do that manually. So yeah, now what we need to do is get that into there. So I'll unscrew the top of this connector. Don't know why I'm showing this much detail, but just skip ahead if you're not interested in watching me put a very basic connector onto a cable. That'll come off. And then take that out. That opens up, and then just need to put these wires into there. I'll do it off camera because if I'm trying to lead in this position, I'll not get it in right because I can't really see properly. But all I'm going to do is put these wires into here. There we go, that's them in there. And this has quite a good strain relief, it's quite grippy, so all I need to do is make sure that's lined up so the sort of outer double insulation of this lamp holder cable's inside the enclosure. That'll clip over like that. Bit fiddly to do in this position because I have no idea what I'm showing on camera. But there we go, get that in there. And then when you tighten the screws up, that very much clamps the cable in. And it actually seals up pretty tightly, which is good. You don't end up with like a gap in the end or anything, so that's really good. So just tighten those 2 screws up. And that'll give me a finished lamp. And to be honest, I can't really fault the original junction box. Like, the only reason I'm replacing this is because I have that 3-core in earth. If I was just using this normal twin in earth, I would just use the standard provided junction box. It's perfectly fine. But yeah, that's it there. So now I've got all these lights all finished off with these junction boxes. So I've got the smaller ones and the insulation coverable ones. Got them all ready. Now time to get them connected up, get bulbs in them, and put them in the ceiling. And there we go, that's them all connected. So that's them all there, hanging quite neatly. These connectors are really, really easy. They just clip in, that's really nice. Very secure. So all I need to do is get these pushed back up into the ceiling. I won't do that on camera because that'll just be, well, no idea how to hold the camera and do that. I mean, I could use a tripod, but that's effort. But yep, should be pretty easy to put up. Just, fold the springs back, push it through the ceiling, and let the springs go. And as I mentioned earlier, the springs are strong enough, hopefully, to hold them up, but they're not like a mouse trap, so they should be easy enough to get out again, which is good. So yeah, that's them all in there. Time to get them into the ceiling, and then turn them on. So the final thing I want to do before I push them up in the ceiling is to do a bit of testing. Which, yes, is probably a bit over the top, and I dare say if I hire someone to put these in, they probably wouldn't do this level of testing, but I just want to make sure it's all okay. So for that, I'm using this multifunction tester, which is a Dialog 9083P. They don't seem to make it anymore, it's a slightly older model, and it's a bit of a oddball form factor, this type, rather than being a sort of traditional, sort of wide, more rectangular MFT. This is more multimeter shaped. But it does everything I would need, so it does insulation resistance up to 500 volts, continuity, RCD tests including auto and ramp tests, and it'll also do loop impedance, and it won't trip an RCD when doing that, which is really good. Obviously a bit over the top to have as a DIYer when I'm not actually undertaking any really advanced work. I'm just essentially replacing accessories here, but I like to be able to check my own work, so that's why I've got this. So I've already done like an insulation resistance test at 500 volts, that's absolutely fine. I'm sure it would be, it's very new cabling. I've also done a loop impedance test, so that's also tested it perfectly fine. The ZS is about 1.7 ohms, which is perfectly fine for a 6 amp MCB. And what I've also done is I've checked continuity, so I'll just sort of talk about how I've done that, and I'll demonstrate doing that here. But basically the reason I've done this is that obviously each of these junction boxes has a lot of connections in it. So each light, all 9 of them, have a junction box above connecting all 4 wires together. And that's just a lot of connections, and what I want to make sure is there isn't a loose connection in any of those junction boxes, because while they're not too hard to do, they're just a bit tight and a bit crammed, and it's not unreasonable that maybe a wire won't have got pushed in all the way or might be a little bit loose. So in order to test that, what I've basically been doing is on the first downlight, I've been linking out pairs of wires, so connecting them together. And then on this downlight, which is the furthest one, I've been testing the resistance between them. And then by doing that across various combinations of these wires, the idea being that each of these is the same 1mm wire, the resistance of every pair of these, every combination of pairs, should be the same. So this is the final one here I'm doing. What I've done is on the first downlight, I've connected together the two lives, so the brown and the black. The two switched lives are connected together at the first light. So what now happens is if I measure the resistance between the brown and the black, that measures the resistance of the brown going all the way back to the first light, plus the resistance of the black coming from the first light back to here. So that resistance will essentially be the resistance of those two wires together. And then by testing that alongside testing, say, neutral to earth, live to earth, or L1 to earth, L2 to earth, and doing all those combinations, if they all give me the exact same value or a close enough value, then I can safely say that there shouldn't be any loose connections. Whereas if I found that whenever I say introduce the neutral, if any of the readings with a neutral involved were significantly higher than any of the others, then that would indicate a loose connection on the neutral. That's what I've been doing here. So I've got this pulled down, the two lives are linked out at the first light, and I've got the crock clips on. So if we turn the tester on, I've already nulled the leads. This one remembers the nulling. So if we do the test, we've got a reading of 0.68, 0.69 ohms. And that is basically exactly what I've got for all the other pairs. So I can safely say that there shouldn't be any loose connections on these junction boxes. And even more satisfying than that, looking at the sort of resistance you should expect from 1mm twin and earth, this is almost exactly the correct amount for about 20 meters worth of cable. And I'd roughly estimate, looking at the sort of lengths involved as it goes around the room, I've almost got exactly about 20 meters worth of cable. So not only have I sort of verified that, you know, they're all matching about the same, it actually matches the resistance I should expect from that length of cable as well. So that's really pretty good. So yeah, a bit of an over-the-top test, but I like to be a bit overly cautious and test more than I need to, rather than just sort of throwing caution to the wind and just plugging it in, turning it on, hoping it works. So yeah. So yeah, that's the testing I've been doing there. Tested the combination, the continuity of all the different pairs of wires, 500 volt insulation resistance test, and obviously just a ZS test as well. So yeah, that's there. So now, finally, we can take these crock clips off, get these wires put back into that terminal block, connect the last light on, push it up in the ceiling, and look at them all working when they're installed. And there we go, that's them all working. And I have to say that I'm extremely happy with how these look. I think they're actually really smart lights. Especially if you turn them off and you look at the lights with them off, they actually look really subtle up there. So much neater than the old ones. So if you're in the room and you're not actually got lights on, they really disappear a lot more than having big metal discs on the ceiling. And because they're flat and they don't have a way to remove the bulb from the front, you've got the benefit that it's a really clear finish. You don't end up with like a ring or like some sort of clip you need to take out. It's a very sort of neat overall finish. If you turn them back on again, you can take a look at them when they're actually lit up. There we go. And I have to say the low glare stuff is actually quite accurate. Now with these bulbs, it's maybe not as big an effect as you get with a traditional bulb. And that's because these are smart bulbs, they're RGB, and they don't have like a lens over the front, they're just a flat bit of plastic. So they tend to throw light out at quite a wide dispersion angle. I also tried these with a traditional 38-degree beam angle GU10, and that was huge. It was like the sort of metal surround around here was really dim, which was really, really good. With these, it does still throw a little bit of light onto the overall sort of surround of the light, because these are quite wide angle bulbs. But if you use a traditional bulb with a lens on it, you still obviously get light on the edge here, but it's significantly lower glare. But even with these bulbs, they are a lot lower glare. And it's something I especially noticed with this front row, because that's above the TV. And if I'm sitting watching TV, I'm kind of sitting at like this distance from it, and you noticeably get less light spilling out from the side, so it's actually quite nice. I also just like how they look, so it's not just the low glare nature, but I can definitely see myself putting these in the other rooms as well, because now when I go into my bedroom or my office, I notice the glare a lot more because I'm used to these ones. So yeah, I'm definitely very happy with them. They just sort of give a view of really what it all looks like, you know, when it's all like just different scenes and stuff I've got. If we turn off the video lights, just so all you're seeing is the downlights, obviously it'll be a bit dimmer. We're going to go through it and we can look at things like colours. So if I switch them over to the colour scene, that's sort of coloured lights I've got, because they're all smart bulbs. And again, I just think these look really smart, because when they're lit up coloured, I don't know, the lights almost just look like glowing disc on the ceiling. It's not like a big metal chunk with like a bulb in it. It just looks like glowing spheres of light, which looks really good. And especially during the day as well, these lights are a lot more discreet. When you walk into the room, you don't really notice the downlights, especially if they're off. And when you turn them on, it does just look like discs of light coming down from the ceiling. Whereas previously, they looked noticeably like downlights. They were very visible metal discs on the ceiling. So these definitely look a lot better. In terms of being able to do maintenance on them, in terms of pulling them down from the ceiling and stuff like that, yes, it's not as good as a sort of traditional bulb or traditional downlight that you can easily remove the bulb from the front. You do have to take it out the ceiling. But I found the springs aren't deadly. It's a little bit more annoying, but given you don't need to replace LEDs that often versus halogen, which seem to blow every second, it's not as big a deal. They're perfectly easy to pop out the ceiling and replace the bulbs in. And unlike the old lights where the springs were like mouse traps and destroyed the plasterboard, these ones, yeah, they're pretty easy to pull out the ceiling, and I'm not that worried about damaging the plasterboard. Although, I've also come up with one quick trick to get them out the ceiling even easier, and that is using these little bits of plastic here. So all these is just a couple of little bits of curved plastic that I literally cut out a drinks bottle. I need to do it with a coloured bit of plastic because I keep losing these because they're clear. But essentially all I've got is two curved bits of plastic. And all I then need to do is when I want to take a light out, I ease it down from the ceiling a little bit so I can see the spring on the side. And I won't be able to do this on camera, but I then slide this up the side of the light and over, so I sort of slide it up like that, so it sits over the edge and under the spring. It's dead easy to slide it in. And that way, when I pull the light out, it slides over this plastic rather than the plasterboard, and that totally eliminates damage. So that's a little trick I've had there. I might even try and make one of those like YouTube shorts or something on how to do that, just because it is quite a neat little trick I sort of came up with. Dead happy with it. But yeah, I'm not too worried about pulling them out the ceiling. The springs aren't deadly, which is good. And then finally, there's one more perk I've found with having a light of this form factor with an open back. And that is, while this one's designed for GU10 bulbs and it comes with the GU10 holder, you actually don't need to use GU10 bulbs with this. And by that I mean, is what you can now get is sort of almost like a hybrid between an integrated LED fitting and a GU10 downlight. And that is sort of, they call them like light modules or 50mm light modules or something like that. They've all got different names. But essentially, it's a a sort of fitting, a light bulb almost, that fits into a GU10 form factor. It's a 50mm wide cylinder. But because it doesn't have to fit the GU10 standard, it can be a bit wider so it can disperse more heat. And it can use an external driver because it doesn't have to connect onto a GU10 connector. And the benefit of that is that those can often be brighter than a GU10 bulb, because that is the one advantage of integrated LED downlights, is that they can be brighter than the GU10 because they have more space to disperse heat and they can have larger drivers. So I'm kind of curious about trying them out, and I might try it when I say fit them in my office where I don't actually have smart bulbs, I've just got GU10s, because that could be a decent hybrid. If you want the additional light output of an integrated LED fitting, you could instead get something like this, get one of those modules with an external driver, and at least then you've got the benefit that if it does fail, you can easily swap the module out, but keep the aesthetic of the front of the light intact, which I think is a decent sort of compromise. So I definitely might get one of those to try out, because it could be an interesting idea. And then interestingly, this is actually something Integral sell. If you're looking at the EvoFire downlights, like how first was, you might actually see some that look like integrated LED fittings, because it's a picture that shows this, it shows a sort of larger back on it, and I thought, okay, they do a GU10 version and an integrated LED version. But actually no. If you buy that version, what you're actually getting is this sort of lamp holder with one of those sort of replaceable 50mm modules. So that's actually a really nice idea, and I think that's the one way I could kind of be okay with an integrated LED fitting, is if it has a replaceable module in the back that you can kind of mix and match from different brands. It's vaguely standardised in the sense of the size, so you can keep the aesthetic of the front if it fails in the future and just replace the module at the back. So that's just a sort of interesting thing I discovered from this sort of form factor. And then the final thing I've discovered, which I really want to try out in here, but I think it's just going to be too expensive, but maybe in the future, is you can also get LED modules of that sort of form factor, but that are RGB. So essentially you've got a sort of cylinder that fits into this form factor. It's a sort of 50mm wide sort of cylinder shape, and it has RGB LEDs in it, or sometimes RGBW. But out the back of that, all you have is a bunch of wires for each LED in it. And the idea is you connect it to an external RGB LED driver. And that's pretty exciting, because even though my budget here probably isn't going to allow that for the foreseeable future, if you had a high enough budget for those, that means that in each fitting, rather than using a GU10 smart bulb, you could fit one of those and fit an RGB DMX driver and actually have RGB downlights connected to, say, an external LED driver that's using something like DMX or DALI, and have fully wired RGB smart lights, rather than this where they're all Zigbee based or Wi-Fi based. You could actually do something really clever. And a lot of that is just all down to having this form factor where you've got a fire rated downlight, but you don't need to worry about the can behind it only being the sort of shape to accept a GU10 bulb. You could fit proper big, LEDs behind here and have external drivers and do all sorts of cool stuff. So yeah, that's a really interesting idea with these. Bit of a ramble there, but I just wanted to sort of talk about that because that kind of opens up a lot of possibilities, and I kind of now want to try some of those out because it just looks kind of cool to play with. I might even just try and get a couple to play with, because even if I can't afford to do the entire room right now, it could be an interesting video, so let me know if you'd be interested in seeing a video on that, because yeah, that's an interesting benefit of this form factor that I hadn't really considered when I bought it. But yeah, you can fit other things into this, not necessarily GU10 bulbs. And there you go. That was a video where I've replaced my existing GU10 downlights with these new integral Evo Flamefire rated downlights. And as I've probably mentioned, I'm very happy with them. I absolutely love the new appearance of them, they're just so much more subtle. The recessed nature really does help reduce glare, especially in rooms where you've got more tight beam angled bulbs, but even in here it still makes a big difference. And I'm so happy with how they look. And I'm almost certainly going to fit these in other rooms as well to replace the existing downlights, because they just look so much better. And when I go into the other rooms, I definitely notice the fact that the downlights are very silver and also quite wide beam angle and glary in your eyes. So yeah, definitely super happy with them. So yeah, thank you very much for watching. And if you're interested in buying these, I'll try and put some links in the description to buy these downlights. But yeah, thank you very much for watching.